Warm greetings and very good morning, dear friends and students. Today we are going to see a analytical problem, the case of long column. You know that the columns are classified into short column and long column. The case of long column, the slenderness ratio lambda is equal to effective length of the column divided by minimum radius of gyration is greater than or equal to 12. Then it is called as a long column. The case of long column, the effective length is given and the Young's modulus of the material of the column is given and the cross section is given. You can find the Euler's crippling load using the Euler's theory. Already you have seen about the Euler's theory and the Euler's critical load for a long column with the different conditions, like when both ends are hinged, when both ends of the column are fixed, when one end of the column is fixed and the other end is free, that is a cantilever column, and the fourth one when one end is fixed and other end is hinged. So for all these four types of column, we have seen about the effective length in terms of the actual length. Here we are going to see about the numerical problem for a long column of effective length capital L, that is equal to L effective, that is equal to 3 meter. He is subject to a load, is axial load only, capital P, and the cross section of the column is 350 mm by 500 mm, and the Young's modulus of the material of the column is 1.5 into 10 power 5 Newton per square millimeter. So what about the effective load or crippling load on a given column? The case of when both ends are hinged and when both ends are fixed. We are going to see the crippling load or Euler's load for these two types of column. Now, the effective length is equal to L effective, that is equal to 3 meter, that is 3000 Newton, so 3000 millimeter. Then you know that the Euler's crippling load P suffix C or P suffix CR is equal to pi squared EI by the square of the effective length, that is capital L square or L effective square. So here P is equal to pi squared, Young's modulus is 1.5 into 10 power 5, and the corresponding I value, you have to take the minimum moment of inertia. It is 500 into 350 cube by 12 by here L square. L is 3000 square. So if you are working out and simplifying the given values using the crippling load, P suffix CR or P suffix C is equal to, you are getting around 3.523 into 10 power 9 Newton. The crippling load or the Euler's critical load is 3.523 into 10 power 9 Newton. If you are converting to kilonewton, you have to divide by 1000. So that is 3.223 into 10 power 6 kilonewton. So this is the crippling load for when both ends of the column are hinged. The case of when both ends are fixed, again the Euler's crippling load PCR, that is equal to P suffix E, that is equal to pi squared EI by capital L square. So the effective length is same for all the four types of column. So you are substituting the corresponding value of the given parameters. P suffix E is equal to pi squared E 1.5 into 10 power 5 into I is 500 into 350 cube by 12 divided by 3000 square. If we are working out, we are getting 3.523 into 10 power 9 Newton. And we are giving in terms of kilonewton, so 3.523 into 10 power 6 kilonewton. So this is the crippling load or the Euler's critical load. If you want to go for the safe load, the safe load P suffix S is equal to crippling load P suffix E divided by the factor of safety. That ratio you have to put. So the factor of safety you can take it for 2 to 4 based on the given material of the column and then conditions. I am taking the safety factor as 2. So 3.528 into 10 power 6 divided by 2. So that is the value, that is 1.26 into 10 power 6 kilonewton in terms of kilonewton for both end conditions of the column. That is when both ends are hinged or when both ends of the column are fixed. So this is about the numerical problem, provided all the unknown factor except the load is given, you can take it. So if similarly, if the load is given, either a safe load or the critical load is given, you can able to find what is the cross section you have to maintain, or what about the flexural rigidity of the column, you can take it, that is the product EI, that is called as flexural rigidity of the column. So that way also you can do it, or you can compare what is the safe load for all the 4 conditions. Based on that, you can give the ratio. What is the safe load carrying ratio or critical load carrying ratio for the given 2 or 3 end conditions of the column. Thank you very much for patient listening. God bless. வாழ்க வையகம், வாழ்க வளமுடன்.